Advanced Algebra Chapter 5, Lesson 2, just a few notes and some problems on how to create quadratic equations when you're given just a point or just some information that you need to substitute into the expression. Remember, we have the expression y equals ax squared plus bx plus c as our standard form of a quadratic. And we also worked with, in this lesson, ax squared, and let me make that x a little bit better. It's just a little messy. Ax squared plus c, where we have no linear term. And the thing I want you to notice particularly about this particular equation is two things. We have four different variables in the expression, a y, an a, an x, and a c. And our job is always to determine everything except the y and the x, because this expresses a relationship between y and x. So we need to determine a and we need to determine c. Now again, in order to determine any one variable in an expression, we need to have all of the variables filled in except for that one that we don't know. And then we can use algebra to determine the final one. So in this lesson, a couple of things we need to know and remember about the values of a and c, what they are, so that we know if we're looking at a problem, if we have that information or not. And remember, c, because there's no linear term, is the y-intercept. So I need to know that, so when I read a problem where they say, give me the equation of a quadrilateral that goes through the point 3,6 and has a y-intercept of 4, I know where this 4 goes. Where did this 4 go? Well, that is the letter C, so I put that in for C. Then all I need to do is figure out what A is. Well, to figure out what A is, I need to have a value for y and x. Well, the point gives me the value for the y and the x, the y coordinate, the x coordinate, and now I have everything that I need to determine the value of A. So it's very important to know what these letters represent, and then simply substitute the values in. The other thing about the y-intercept is to understand is remember that they don't always say the y-intercept. They may give it to me in its mathematical form. Remember, if the x-coordinate is 0, all of the y-intercepts have an x-coordinate of 0 because they're all on the y-axis. So whenever they give me a coordinate that has 0 as its x-coordinate, this value here will be the y-intercept. That will go in for C. So another example might be, let's see if I can erase some of this without messing up everything. I'm going to have to rewrite that, so let me go ahead and rewrite that. Ax squared plus c. So another way they might give it to me, they might say, give me the equation of a parabola that goes through c 3/6 and the point 0.07. Well, again, I need to recognize, well, this has an x-coordinate of 0, therefore that's the y-intercept, so that goes in for C. And again, I need to determine A. Again, I have a y value and I have an x value, so I substitute those in, I solve for A, and I have my equation. So remember, these two things about the y-intercept, it's very important to remember to recognize what the y-intercept is. The second type of problem we might have is where we're given two ordered pairs, but neither one is the y-intercept. So what are we going to do in this case? Remember, we need to determine A and C. And what we want to do in this case is let's just substitute these values in for y and x and see if it leads us somewhere. So I have this coordinate, so let's go ahead and substitute this in for y and x. So I have -10 is my y value. That doesn't look like a 10, it looks like a 6. -10 is equal to a times my x value plus c. And if I simplify this as far as I can, squaring -2 is 4 plus c, I have an equation where I have two variables. Now remember, if I have two variables, I need a second equation. So all I need really is a second equation to create a system, and then I can use substitution or elimination. Well, here's a second ordered pair, so let's substitute these in and get our second equation. So here I have a y value. How come I keep making my zeros? It looks like sixes. I don't know what that is. 0 equals a times the x value squared plus c. So this is going to give me -40 is equal to 16a plus c. Well, what do I have when I put this over here? I have a system of linear equation that use the same variables. And now I can use substitution or elimination to solve this. So I can use elimination because these are almost opposite. So I'm going to multiply this first equation by a -1, changing the value of all of these. And then I'm going to add these together. So -40 and 10 is 30. This is going to be 12a. That's -30, excuse me. And then the c's eliminate. So a then is equal to -30 over 12, which simplifies to -5/2, dividing both by 6. I now know what my a is. I can then substitute this back into any of these equations that I have to determine the c value. So I'm going to go ahead and just substitute it in here because I have more room over here. And so the 2 and the 16 reduce, so this is -40 is equal to 8 times -5, which is -40 plus c, solving for c, so c is 0. So I have my a value, I have my c value, I simply substitute these into the expression then, and a value is -5/2 x squared, c is 0, so I don't need to write it. So this would be the equation that goes through these 2 points. So whenever you're given 2 points, the 2 types of problems we have, if we know what the y-intercept is, it's simply put the c in, put the other coordinate in, figure out the a. If neither one is the y-intercept, I still do the same thing. I substitute in the values that I know, creating 2 separate equations, which I can then use substitution or elimination to determine the values that I need. That's going to be a common problem that you want to do when you're given 2 points. It's just substitute it in and then go back to substitution elimination. It's going to be something that's going to be very helpful to you.